Hello. In this video, we are going to see about programming for permutation in assembly language using EMU8086 and lab hardware kit. So in previous video, we have seen about finding the factorial. Factorial extension of factorial is going to be your formula for your permutation. So we can able to see what is the formula for your permutation first. So this is your formula for your permutation. So n factorial divided by n minus r factorial. So in this case, if you are going to take in terms n is equal to 6 and your r is going to be 4. So what is your final output which you are going to expect it? So it is going to be 6 factorial divided by 6 minus 4 factorial. So if you want to convert it into formula, so that it is going to be 6 into 5 into 3 into, 4 into 3 into 2 into 1. So 2 factorial, which is going to be 2 multiplied by 1. So in this case, we can able to directly cancel this one and you can able to get your output. So it is going to be multiplication. This is going to be 30 and 30 is going to be multiplied with 4 so that you can able to get the value of 120. 120 multiplied by 3, it is going to be 360. So 360, or if you are going to solve it in some way, it is going to be 720 divided by 2, so that it is going to be cancelling out, it is going to be 360. So your final value is going to be 360. So your output, which you are going to see in your microprocessor kit, will not be 360. It is in hexadecimal value. It is in decimal, right? Actually, what you have calculated is in decimal. So if you are going to see it in your hexadecimal calculator, so you can able to do the operations in manually also. Else you can able to do it in your hexadecimal calculator. So you can able to move to the logic, how we can able to solve this one. So first, we have already done factorial, right? Same logic. So your final output is going to be 360. Your hexadecimal equivalent will be 168. So you can able to check that also. So keep this one, and I have already tried this one. So 360 is going to be 168 in terms of your hexadecimal calculation. So I can able to take 168 directly. So that will be my output. So in this case, how I can able to solve for this logic? So first, I need to write a program for my factorial. So already I have written. So how I have written? So I have moved my value of this one. So if it is going to be 4 factorial, how I have written? So I have initialized my AX is going to be 0, 1. After that, BX with the value of AX. And after that one, I have incremented my BX. So after that one, I have tried to multiply it. So increment my BL, right? So this is what I have done in previous program. Multiplying my BL with my AL, and I can able to save it inside my AX. So after that one, I have to decrement my CL. So it is going to be a count register. 4 factorial is 4. So your CL should be 4, right? So this is what the logic we have seen. So after that, we have seen 2 logics, right? So it should be compare operation, and after that jump carry verification. Else I can able to check for jump no 0. So till this time, the loop has to be continuing again and again to this point. So now the formula here is going to be n factorial into n minus r factorial, right? So first, initially, I know what is the value of n and r. So n is going to be, so for an example, I have given it as 6 and r is going to be 4. So first I have to subtract both the things. So 6 minus 4 is going to be 2. So first I have to find my 2 factorial and 2 into 1, and I have to put it in some register, any register. After that one, I have to find the value of n factorial, which means 6 factorial. 6 factorial is going to be 6 into 3, 5 into 4 into 3 into like, so I can able to get those values, right? 6 into 5 into 4 into 3 into 2 into 1, which is going to be 720. So this is going to be 2. So 720 divided by 2. So which is going to be getting the value of 360. So actually it will not be 360, it is going to be 168 in hexadecimal. So first I have to subtract those values, put it in a temporary register, find the factorial of this one, keep it in a register, and after that one find the 6 factorial and move it inside any of your register. And after that one, I can able to divide both the registers, 720 divided by 2, and I can able to save it inside any of my registers. So division operation happens on your AX, right? So saved value will be in your AL register, right? So quotient will be in your AL register. So if there is any reminder which is going to come, so that will be in terms of your how you are going to take it, whether it is going to be DIV BX or DIV BL, both the things which you want to use. So if it is going to be DIV BX, so you can able to see your quotient in your AL and your remainder in your DL, right? So if it is going to be DIV BL, so you can able to see your quotient in your AL and remainder in your AH. That is what we have studied while you are moving in terms of instructions. So we have to be a little more careful while you are using your divide instruction. So this is the logic. So with this logic, I have to do my program. So here I'm having many jump statements, right? Because I have to calculate my factorial, and after calculating my factorial, I have to jump, no zero. So for 2 factorial, 1 jump. For 6 factorial, 1 jump. So after that one, I have to divide it and I have to find my final operation with the help of my division operation. So the same thing, I have tried the logic with terms of your EMU8086. We can able to check with that one. So this is the logic. So I have moved the value of n to the memory location of 2000 and r to the memory location of 2002. After that one, first I have to subtract both the things, right? So subtracting of both the things, I can able to put it inside my temporary register, any of my register. So I am putting it inside my DX register. So after that one, CX has to be moved to my CX, which is going to be count. So after that, I have to initialize my AX to be 0001, right? So in reverse logic, we have already calculated same one. AX is going to be 01. So after AX is going to be 01, so multiplied CX, decrement CX, jump no 0. Previously, it is going to be compare and jump carry, right? This here I am using the logic of jump no 0. Jump no 0 should be repeating its loop again and again till your CX value becomes 0. So after that one, so our final value, whichever I'm going to have, will be in AX. So I will move that value to my BX. So after that one, I have to calculate the 6 factorial, right? So now I have calculated the 2 factorial. After that, I have to get the 6 factorial. 6 is there inside my memory location of 2000. So I can able to move that value to the count register now to calculate the 6 factorial. And after that one, AX is going to be again 01, same. Multiplied CX, decrement CX, no 0, loop 2. This loop is for your calculation of your 6 factorial. Divide BX. So after that one, the value of AX can be moved to and memory location of 2004. So where I can able to see my results. So while I'm running my program, so I can able to check for my logics parallelly. So whether it's working. So I can able to take my memory component separately, and after that I can able to take my flag status separately. So I have taken the starting address of 2000, right? So again, I have to get it in terms of my 2000. So here I can able to enter my 2000 here. So here I have to enter the n value and your r value, right? So n value I have taken in terms of my DX and CX, which is going to be 16-bit register. So if you want, if you are familiar with good in terms of 8-bit calculation, you can able to do with 8-bit calculation. So I have taken it in terms of 16-bit register. So CX or DX, whatever I am going to take, it should be 16-bit, right? So lower bits has to be given in the first memory location. So it is going to be 0006. So 06 should be reaching the first position, and after that 00 should be reaching the second position. So after that one, it should be 04. So 0400. So first is going to be lower nibbles and next is going to be higher nibbles. So 0006, 0004. I'm putting those values inside my DX and CX. So now I can able to check whether it is running. So I can able to move that one. DX is going to be 2000 So I got that value. That Cx will be 2002. So I got this value of 2000. So dx will be having the value of 06 and Cx will be having the value of 04. So 0006, 0004. That's why I have given this memory locations. So after that one, it should be move Cx comma dx. So it is going to be subtraction operation, right? So dx comma cx is going to be subtracted to each other, so that this dx is going to be getting the 2 factorial, which we have seen here, right? So 2 factorial we have got it. So 2 value of 2 we have got it. After that I have to calculate my factorial. If I want to calculate my factorial, so ax should be given with 0001. So ax got the value of 0001. So I am moving that value to count register. So that many time I have to count this loop, right? So multiplied by cx. So all those operations will be executed one by one. So the loop has to repeat again till it's completing its 2 factorial. 2 factorial is completed. So previous step. So 0 flag has been set. So when finding its 0 flag to be set, it will jump out of the loop. So bx comma cx. So this bx is going to get the value of bx comma ax, which means ax value is moved into your bx. And after that one, I have to take the 6 factorial, right? So this 6 factorial, I can able to move to 6 values. I can able to move it to the count one, so that I have to calculate my 6 factorial. So again, after that one, I have to repeat the loop 6 times. 1, 2, 3, 4, 5, and 6. So 6 it's completed. So after that one, 0 exists. So previously no 0 exists. After that one, and I am going to compare your cx should be equal to 0, right? So after executing this one, so your cx value will be 0. So decrementing of 0. So it is going to check for its condition as 0. So cx is going to be 0. So when it identifies it is going to be 0, it will jump out of the loop, so that it is going to be performing the next division operation. So now I have my, so total 6 factorial in terms of hexadecimal is going to be 0 to d0. So after that one, I have to divide it with 0 to. That is what I want. So after that one, I can able to move in terms of your division operation, divide bx. So these values will be divided with each other. So after that one, I can able to get the value of 0168. Right, that's what I want. So finally, I have calculated 168, right? So it is going to be 0168 in terms of your AX register. So after that one, I have to move that value inside my memory location, right? So memory location, whichever I want, is going to be 2004. So 2004 is going to be 2000, 2000, 2001, 2002, 2003, 2004. Here, your output has to be coming up, popping up. So your output should be 68 and 01, right? So next operation, it is going to be 68 and 01, which is going to be saying that 0168 is your final output answer. So this is the logic for your permutation. So here I am having loop 1 and loop 2, right? So instead of loop 1 and loop 2, I have to give the memory locations in my hardware programming. Only those changes I am going to make there. So in order to identify that memory location, first I have to start typing the program, and I can able to check with the starting address, and I can able to move it. So permutation. So here I can able to see the values how I am going to get. So 2000, 2002 subtraction. So 6 minus 4 is going to be 2. So that value of 2 will be inside your dx register. So the dx has to be moved to cx register. So it has to count. So one by one. So it is going to be identifying its 2 factorial. To identify its 2 factorial, ax will be 0, 1, multiply cx, decrement cx. So this value should be taken from here. Right? So while typing the program, I know this memory location, and I can able to give the memory location here. So after that one, this is going to be jump no 0, and after that one, 2 factorial has been identified, and the value is going to be in your ax. So I can able to move that ax value into bx. So 2 factorial is going to be 2. So 2 is going to be inside your bx register. So after that one, I have to take the value of 6, right? So 6 is going to be taken, and factorial for 6 has to be identified, so that this count register should be declared with 6. So the 6 is there inside my memory location of 2000. So after the same operations, cx, ax, decrement, jump no 0. So this memory location should be this memory location. So this is also good. And after that one, I have calculated my 6 factorial now. So it is going to be 0 to 2 0, right? So that one has to be divided with. So this is having your ax is going to have the whole the value of 6 factorial. Bx is going to hold the value of your 2 factorial. So divide Bx is going to divide your dx along with your ax, and it is going to put its final output of quotient inside your ax register. So ax is going to hold the final value, and it is going to push that value inside my 2004. So your output values at 2000 is going to be, input values at 2000 is going to be the memory location. So location 0600, and after that 0400. Final output should be 6801. So it is going to be 168. So this is what the logic, and I can able to check in terms of my hardware whether it is going to be executing in the same fashion which I want. So I have already typed the program. You can able to directly see the instructions. So starting address of my program, which is going to be 3000. Enter. That one dx getting the value from 2000, cx 2002. That one I have to subtract. So that's 6 factorial. 6 minus 2 is going to be 6 minus 4 is going to be 0 2. Cx, I'm moving the value of dx to cx, and after that ax is for finding 2 factorial. So starting ax with 0 0 0 1 multiplying. So I'm going to take the memory location, decrementing cx, jump no 0 to that multiplication operation, incrementing operation. After that 3015. So I'm using the value to bx, cx 2000, ax with 0 0 0 1 again, multiplying cx, incrementing cx. So finally verifying whether it is going to be 0. So after the division operation, and after that pushing that value inside my 2005. So here it is going to be 2005. So after that one, I can able to check with my values or enter my values in the specific memory location. It is going to be 2000, right? So after entering, it is going to be 06. I can enter the same value 06 again, and after that 00, 06, 00. After that 04, enter 00. Enter. So I got all the values input. So after that one, I have to execute my program, reset. I have to press my reset. And after that one, I have to execute it, go command, starting address of my program, 3000, executed, resetted, go to that specific memory location, 2005. So it is going to be 68 and 01. So 0168, 168 is your permutation values. So like this, I can able to calculate permutation for whatever digits I got it in terms of my input values of N and R. So try this program with your hardware kit. Thank you for your patient listening.